low-E drives embed friends. In the last video, we assumed that the switch changes the DC component of the input voltage. We have also assumed that the average value of the switching voltage Vs is D times the input voltage. From Fourier analysis, we know that the DC component of a periodic waveform is equal to its average value. Hence, the DC component of the voltage Vs is the switch changes the DC voltage by a factor corresponding to the duty cycle D. To convert the input voltage of 100 volts into the desired output voltage of 50 volts, a duty cycle of 0.5 is required. Here too, the power dissipation of the switch is ideally zero. When the switch contacts are closed, their voltage is zero, and the power loss is therefore zero. When the switch contacts are open, the current is zero, and the power dissipation is zero again. We have therefore succeeded in modifying the DC voltage component with a device that is ideally loss-free. In addition to the desired DC component Vs, the switch output voltage waveform Vs of T also contains undesirable harmonics of the switching frequency. In most applications, these harmonics must be removed, such that the output voltage Vt is essentially equal to the DC component Vs. So, a low-pass filter can be employed for this purpose. If the filter corner frequency f0 is sufficiently less than the switching frequency fs, then the filter essentially passes only the DC component of Vst. To the extent that the switch, inductor, and capacitor elements are ideal, the efficiency of this DC-DC converter can approach 100%. This is a typical way in which the two-position switch is realized using switched-mode semiconductor devices. Control system for regulating the output voltage is introduced. Since the output voltage is a function of the duty cycle of the switch, a control system can be constructed that varies the duty cycle, so that the output voltage follows a given reference. This converter power stage is the so-called buck converter, because it reduces the DC voltage. Converters can be constructed that perform other power processing functions. For example, this circuit is known as the boost converter, in which the positions of the inductor and two-position switch are interchanged. This converter is capable of producing output voltages that are greater in magnitude than the input voltage. In general, any given input voltage can be converted into any desired output voltage, using a converter containing switching devices, embedded within a network of reactive elements. Thank you for watching.